Alright, in this video what we're going to do is actually update you on the registration. So what we're doing is we're using a K6K or Kinetix 6000 drive. We're using version 32 and the processor is a L73. Now we've added some controls to this, and again, if you haven't seen videos 1 through 3, go back and watch videos 1 through 3 and you'll see exactly what we've been building upon. But what I've done is I've actually changed from registration input 1 to registration input 2 because there was an issue on registration input 1, and I've changed from using a push button, so just to show you how things were working, to an actual photo eye. So and this photo eye has a little small sliver of reflective tape on the actual wheel. So if I were to actually turn this wheel, you can actually see the reflective tape that is right here. So I believe it's right here, very bottom. You can see the reflective tape right there. So the photo eye is on the back side right here, which you can't see because that's just the way the camera is right now. But again, when it comes down to it, I can actually show you that if I were to index this and show you that on the input. Now we're going to show you all this running, but let me just show you that real quick. So you can see right here, if I turn this, you can see the registration come in and the actual input come in. And if we actually go to the input status and monitor the tag, right? We monitor the tag, we go down to the registration input of our actual controller. This would be registration 2. Now if I come and index this over, you can see it went high right there. So I switched to registration input 2, and again this is using the wheel. But again, let's go ahead and actually run this and actually show you. So what I've done is I want to actually explain this too, because I've actually changed the controls so that it would better fit this environment. So if you've seen videos 1 through 3, you've seen everything kind of structured together. What I've done is I've actually have the arm in its own command or in its own routine now, have the disarm in its own routine now, and then what I also do is I've changed the actual the event from the event-driven task. I've changed that to a periodic task, which is a 6 milliseconds. Now, why did I go 6 milliseconds? Okay, so I'm going to explain that real quick. In the motion group, if I come down to the motion group, I have my motion group set at 4 milliseconds. So the update of my motion group is 4 milliseconds. So what I want to do is I'm going to do 1.5 times to 2 times my actual course rate update of my servo. Because in a Kinetix 6000 or Kinetix, the Kinetix 6000 and an L7 processor and an L6 processor, the way that the system works is basically that your update time of your course rate of your servos, so how many times you're updating your servo data, right? Servo data right here, this is going to be every 4 milliseconds. Okay, so now it's only taken less than a millisecond, but I'm updating it every 4 milliseconds. Now I'm requesting for that data. Now, and then I'm going to go ahead and scan this specific task, this product tracking. That's 6 milliseconds. So I'm coming in doing that, and then my priority is a 4. Now, my only reason my priority is a 4 is because my other priorities, like this one is a 12, this one is a 10. This one, if I come down here, is an 8. This one is a 9. And again, so you can kind of see the priorities matter, right? So let's go ahead and run this so you can actually see the product tracking. And I'll show you and briefly describe the way the product is tracking, right? So what I've done is I've added some different logic to this to control this. As you see, if you've watched videos 1 through 3, again, this is video 4. This is the completion of it. So I wanted to give you a full spectrum of how actual programming should be, or similar to an actual registration of a photo eye based upon an actual real device, a real wheel, or like a real servo running in a real tracking system. So again, when it comes into it, I'm saying, okay, so every time the ARM PC or the ARM process complete happens, I'm going to do a GSV. I'm going to grab the position of the servo. Then I'm going to say, okay, so every time that the arm is not complete, I want to load that position into position 1. Okay, then at the same time I'm going to do position 1 minus position 2 and get the event length. Now if the arm PC is actually on, right, the process complete is on, that's when I'm going to load the actual position 1 into position 2, and that's how I'm getting my basically my math done, right, the subtraction. Really simple. Let me show you this. Let me crank this up and let me show you this running. Now it will get a little loud because this system will run. It does have a fan on it. So let's actually run the system. And what I'm going to do is I'm going to actually show you the trend of this. So you can see we're tracking the event right now, and no matter what speed I should be running, the wheel, the dimensions of the wheel are basically in where there's one piece of reflective tape on this wheel. One piece, and that's it. So it should roughly be around 1, anywhere between there. So let's actually open up the trend and show you that. So you can see where I started, right? Now what I've done is I have the IP in here, the PC, so the in process of the ARM, the PC, which is the process complete of the ARM. I have the input status, which is registration input status 2. I have the registration event status, or ARM status, and then I have the registration event status. Now I also have the product linked on the very bottom, so you can see the product link down here in this turquoise color. So and the reason I'm doing that is so you can see the product length and see it fluently, right? So see it nice and easy and see it the way it actually is corresponding. So no matter what speed I run this, so if I slow this down just a little bit, I'm going to slow it down, you're going to see that the registration length keeps constant. So if I go back up to my controls up here and I go back into right here, you can see that no matter what speed I'm running, the registration length stays proper, right? It stays correct. Why? Because we're using registration. Now, I will tell you that the registration photo eye that I'm using is not rated for high-speed inputs, so the actual way I'm not actually able to run this system full speed, but I am able to run it at a lower speed and then run it at a decent speed so you can actually see it tracking. But no matter what speed I'm running, so as you see, I can change the speed and it fluently stays exactly what it's supposed to be. Now the reason it's doing this, now I want to kind of go through this, is because the way we're arming, right? So think about this, and this rung up here, this no operation doesn't even need to be here, right? So I basically have it in there for status. That's all it is in there for, just for status, so you can actually see the process working. Now, so what we're doing is we're saying, okay, so if the registration event is not active, and or if the registration status, so this is the actual photo eye, if it's not on, then the event is not armed and the actual instruction is not in IP, which is in progress, then we're going to go ahead and fire it. Now, if you've watched videos 1 through 3, and I suggest you do, again, because video 1 shows you how to wire everything, video 2 shows you, the progress of what we've done, video 3 drags into actually showing you registration, and this video will be closing that out. Now, but again, when it comes down to that, understanding the way that the process fires, you need to have your event armed every time your input comes in. So if you notice in my actual trend down here that I made, every time that I'm firing I'm getting an input, I have an event, right? I have an event there. Now again, I can scroll these out so you can see them even better. So if I want to change this to 45 seconds, if I want to change this to 15 seconds, you could actually see it maybe a little bit better, or maybe even, let's just go quicker than that, so maybe you can see it better than that. So let's go 7 seconds just to cut it. So you can see these coming off and cutting on. So you can see those fluently cutting on and cutting off. And by the way, if you're having video quality issues, make sure you click the little gear icon on the very bottom right hand corner. Make sure you get the very best quality. You can adjust your quality no matter what, because again, I do record in 1080p and I record in 4K. So you should be seeing this crystal clear. And if you're not, that's your it's probably your internet connection, you know. So, but with that said, I want to make sure that we put this back the way it was. Okay, so now you can see these coming on and cutting off, and you can see the actual position working. Now again, I'm going to cut this on a little bit faster, but again, when it comes into it, the event registration is working properly. It's working 100%. And I want to make this one last video to show you a photo eye working off of the wheel, working off a little piece of reflective tape, so it can see every time that wheel spins is hitting the same position every single time. Not the same position of the servo encoder, but the same exact position on the wheel. Meaning, if you had a product, say for instance, if you were like trying to get the product length of a belt, like a product traveling on a belt or something like that, every time that product would hit this certain spot, you could measure the leading edge or the trailing edge. Now, one thing I did do on the arm is I changed it from a positive edge to a negative edge. That's just because of the simple fact of the way the photo eye was responding, and the best way you can actually do your controls. Now, I will tell you this: every setup of registration is done differently. Okay, so if you can think it, you can do it. Now, we've talked about that before logically, but when it comes down to it, every setup for registration in your servo is done differently. I've explained my scenario. I've explained the scenario that I'm doing is a motion group, which is a course rate update of, again, 4 milliseconds. I've explained that I am doing my tracking within 1.5 times of my course rate update, which is going to be 6 seconds. So I'm giving it 4 seconds plus 2 seconds. That's 1.5 times my course rate update. Then I'm giving my servo time to update before I'm requesting information from it, before I'm arming, before I'm disarming, or before I'm doing anything like that, right? So when it comes down to it, and again, I don't disarm unless the motion group is not synced, if there's an error with my arm command, or if the action status goes off or comes on. Now, these are one shots, okay? So I'm not actually doing this all the time. It's only one shot. Now, in the main routine, that's where, before I even call the JSRs for the arm or the disarm, what I'm doing is I'm doing my actual math, and I'm grabbing my information so that I can do my math for my actual calculations and stuff like that. Really, really, really simple stuff. So when it comes to the math, I want to keep the math as simple as possible, because understanding the key for these videos, these series of videos that I've done, these 4 videos, now the key to this is actually going and understanding the way that registration should be set up and the way that input should be done, right? So that if you understand the registration of a servo, again, when you come down to it, you can do just about anything. Now, and again, I want to highlight that, because it's very, very, very important you understand that, because I just sped it up again just a little bit, and you can see, no matter how, I have to be real particular on how fast I cut this on, because that photo eye is not set to, it's not a high-speed photo eye. So your devices matter too. But let's go open up our trend down here. You can see this is spiking. It's not spiking. It's actually staying the way it should. This is the product length. Okay. So the product length, you can see it varying just a little bit, right? You see it varying just a little bit, and that's important. But that's actually showing you that. So let's actually come in here and let's show that. And we can try to crank it up, but I don't think it's going to actually respond, because of the simple fact that my photo eye won't respond. Let's see. And it actually is holding and doing well. So, and this is full speed. So, and again, it may just be that the trend's not updating as fast as I want it to, from what I'm seeing. But the events are firing, the registration is doing what it's supposed to. It's just this one photo eye status is not actually firing at that point in time. It may just be because of the way we have our chart and how fast we're scanning our chart, as far as how fast we're scanning the chart for the triggers and the starts and stops and stuff like that. That could be that as well, but it does appear to be, working 100% and actually registering the way it should, even at a high rate of speed. So when I did test it earlier, I was somewhat concerned with that because this photo is not rated at that. But again, I just brought it up to full speed, and let's bring it down. And you can see that full speed rate off of my, you can see the speed changing off of my HMI. If you want to, you can see that right there. So that, you can see that fluctuation. Now, what I want to do real quick, being that we know that it works at a higher rate of speed, because I was just really testing this stuff out right before I did this video. Being that we did a higher rate of speed, let's actually take it up and down at a higher rate of speed and make sure our actual product length down here stays good. Right, you'll see it actually fluctuate. Okay, so you'll see it actually, if you were to see it actually go like shoot up to, you know, the top bar or the negative bar. This is actually rated at 3. So I have my chart set at let's see, I have my chart set at -1 and 3. So if you actually seen it go out of spectrum, it would have did a huge jump here. So it's actually holding really well. And that's again because of how we're doing our tracking. Again, understanding the way the servos update and stuff like that is really important. So if we change our speed up and down, this is, so now you're seeing it go completely out, right? And you see that's when the photo I pick back up in here. That's just a simple fact of the way that could be just the trend and the way that's working. But again, come in here and we'll do speed it up a little bit. You can see that going like that. So you can see the variance and the difference behind this. Now, again, the reason I highlight all this and I bring all this up is because it's really important how you're doing your math in here as well, how you're triggering that, and also the structure of your program. Okay, so if you can understand the way that the registration is done. Okay, so I'm gonna actually cut this off just so you can see this, and I can get a little bit. It's kind of loud, to be honest with you. So let's cut that off. Okay, everything cut off. It's just going to be just a second, but I want to actually describe this to you because it's very important if you understand the way the servo is actually registering. Alright, so again, I can't highlight this enough. My system is set up at the motion group at a course rate update of 4 milliseconds. Okay, now what I need to do for here, now I could have this event driven if I wanted to, but I decided to go periodic tasks because anybody that's ever seen me program before, you know that periodic tasks is pretty much my favorite thing to do because you can understand your timing so critically, right? You can break down your timing of your machine and understand exactly what you're doing with just the simple timing of the machine at all. I mean, for the simple task, right? So if you've seen the way I just did that, it's 4 milliseconds for my course rate update for my motion. It's 6 milliseconds right here, 6 milliseconds for my actual periodic task to update. That's where I'm doing all my arm instruction, my registration arm instruction, my disarm instruction, and my math for my servo. Now if I'm doing all of that, I'm letting my servo update within 4 milliseconds, and then I'm commanding all that data. I'm taking all the data that the servo gave me, and within 1.5 times of the course rate update, when I'm getting my data, I'm actually using my data. Okay, so I can go to 8 milliseconds or even higher, but again, when you go into higher spectrums, you may see some different variations of that. But again, as long as your controls are right, you can see things. Now let's actually do that real quick. Let's change this from a course rate update from 6 to 8 or even 12 and give it more time and show you the reaction from that. Now I'm going to crank this back up, and I know you guys have been watching this video and I appreciate your patience behind this, but I want to actually show the way this works and the reasoning behind why I'm doing what I'm doing. So you can see it's actually holding pretty good for that speed. So as long as you're not going above or going faster than your course rate update. Let me actually do that. So let me change this while the trend is running. Let me change this to 4 milliseconds. And let's see. So So that's actually not, see where it's not responding right here? You see where we're starting to drop stuff? I'm going to stop this trend for just a second. You see where this is dropping? This is dropping the actual PC, which is the process complete. It's not firing, which is not firing the IP. So that is where you're going to get into a problem. Okay, so I'm going to start running this again. You're going to see the same exact thing because I haven't changed this yet. Okay, so you're seeing the same exact thing. So if I take my course rate update and I took my periodic task and I matched it with my course rate update, it doesn't make any sense because I'm requesting data. I'm trying to use the data as soon as I'm actually trying to use the data as soon as I'm requesting it from the actual servo motion group, right? So if I put this at 6 milliseconds, 1.5 times what my course rate update is, it starts to work perfectly, right? So it'll start falling into spectrum. Let's actually do that, get that back working properly. You can see it starts to fire right. Let's actually take that and may just take it just a second. Actually may have to, the way this thing is, you may have to start and stop it just so you can get it back into natural reaction. And that's, again, that's the way the controls are done. That's the way that the system is operating. So, and as long as you give it 1.5 times, and in this case we'll give it 2 times, so this would be 8. So this is 8 milliseconds. And we're still tracking we're still tracking everything. This could be the trend itself. Let's actually take that sample rate of the trending samples. We'll have to stop it to change that. Change the sample rate, and we'll change the sample rate to our actual course rate update, our actual periodic task. Let's see, sample period, milliseconds. You go seconds, milliseconds. Let's change this right here. Come in here, start this back. And see, even that hurt it. So let's see if we can get it faster than that. Now, taking your trend faster is you may or may not have a problem, because trends are not meant to go as fast as this, especially when you have high-speed stuff going on in your program. Your trends they're really memory restrictive, and they consume a lot of memory. So let's actually come in here and show. Everything is working though properly. So this could be the actual trend, and it could be something with version 32 as far as that goes too. But you know, because that didn't start acting up until I actually changed this periodic rate, and it worked perfectly at 6. So the reason I wanted to actually show you that 100% tried and true, because this course rate update, the natural progression of everything should be course rate update as the time that you're requesting data from your actual servos, and if you're going to use that information, it should be within 1.5 times, at the very least 1.5 times of what you're using it for. Okay, so just understand the process of that and the way that it works. Now again, this trend, the way the trend is working right now, could very well be just the way that the process is scanning and the way that the trend is scanning. I'm not gonna and just by starting and stopping the trend, so that tells me just by starting and stopping the trend, everything started working back properly. That kind of tells me that it's just the trend and how fast that the trend is working, because I got it at 1 millisecond right now, and the processor is probably you know, having a restriction as far as that goes, as far as memory, but I doubt it as far as the memory restriction. I just think that it's taking priority over, you know, running the system over graphically representing the system. So if that makes any sense, your trends are not as critical as your operation of your actual machine. So your trends could fall short at times, right? But this is a version 32, and it doesn't, I'm not going to name it on the version or nothing like that. I'm just going to say your trends could fall short from your actual what you're doing. But again, when we're running and we're running everything the way it should be run, everything's tracking 100% right? Everything's working the way it should. It's tracking the product. It's actually seeing the photo out. It's actually seeing everything working. It's actually fluently doing what it's supposed to be doing. So I wanted to show you a real tried and true way to actually track product and track a system with registration. So hopefully you enjoyed that video. And again, if you haven't watched videos 1 through 3, you're kind of missing out. So I wanted to give you and I know these videos are long, but I want to make sure you watch all of the whole series of 4 so that you can get the very best from this. Because when it comes down to it, knowing servos and knowing the registration behind it, I mean, you can do just about anything you want to with your systems. So again, hopefully you enjoyed that video, and we'll see you guys on the next one.